Okay, welcome to the first video of topic 4, 4.1, miscibility and solutions. In this video, we'll be talking about these things. All right. So solvents can be considered as polar. For example, water and methanol, or non-polar, hexane, turpentine, petrol, and so on. Identify water as a polar solvent and hydrocarbons as non-polar solvents. That's what you need to be able to do. Next, polar and non-polar solvents do not readily mix. You need to be able to identify a solvent as a polar or non-polar based on its miscibility with water and hydrocarbons. Highly polar molecule substances are more soluble in water than non-polar molecules of a smaller size. Sorry about that. Second bottom, molecular substances with small molecules are more soluble in water than larger molecules of similar polarity. You need to be able to predict, given a structural formulae, which of two compounds would be more soluble in polar and non-polar solvents. Finally, compounds with non-polar and polar or ionic compounds facilitate the mixing of polar and non-polar substances. All right, let's have a look. So we'll be watching this video to start with later on. So before we start, we'll talk about terminology, and we watch the video, and hope you will remember what the solute, solvent, and solutions mean. The word solubility means the amount of solute which can dissolve into, the amount of that which can dissolve into solvent, which is affected by substance's molecular structure. Now, if you remember, hope you remember, that the molecules can be considered as polar or non-polar, which affect their solubility. All right. Next, concentrated or dilute. Now, we've used these words, but never really talked about what it actually means. The concentration means the number of particles in a given volume. So, for example, vinegar is a solution of acetic acid or ethanoic acid. For the vinegar that you get, it's about 4 to 6% off the shelf, 4 to 6% of, say, 1 liter. So if it's 1 liter, 4% would be what? 40 mils? Yeah, so that would be what you'd expect to be consisting that vinegar. So how much solute is in the solvent? Now, solute is usually solid that can dissolve into water or something. So amount of solute, say salt or sugar into water, would define how concentrated sugar or salty solution is. If it's seawater, I think it's 3%-ish of sodium chloride dissolved into. It's not much, is it? But it's very salty. All right. Solubility versus miscibility. It's pronounced as miscibility, I believe. Soluble means quantity of solute is much less than solvent. That's one thing that you need to understand first. So we'll do a comparison here. So soluble on the left-hand side, a substance that can be dissolved in a particular solvent. For example, well, what can you come up as an example? The substance that can be dissolved into a particular solvent. Come up with an example, and we'll discuss on that. Now, on the other hand, what does it mean to be insoluble? Well, a substance that cannot be dissolved in a particular solvent. Again, try to come up with an example. Just one simple example is fine from your daily lives. So we are versing solubility, soluble or insoluble, to miscible. Miscible, make sure you know the spelling there too. And miscible means can be equal amounts. So something that you're dissolving or trying to mix into is the same amount as the other thing, all right? So solute and solvent is usually, can be same amount, can be a bit less, but not like, tiny spoonful into 1 liter type of thing. That's more to do with solubility, all right? What does it mean by miscible? two liquids which can be mixed together to form a single liquid. So picture something like, I don't know, cordial or alcohol. Yeah. Well, I just gave you a bit of example, didn't I? Come up with your own. All right. Immiscible. What does that mean? Two liquids which can be mixed together. Oh, sorry, cannot be mixed together to form a single liquid, because it's an opposite of miscible, isn't it? Immiscible is a opposite of immiscible. Come up with an example. Now, on the next slide, you see polar and non-polar solvents. I'll zoom in a bit here for you. Now, common polar solvents include what you see down here, water, H2O, two sites where hydrogen bonds can occur. So it's highly polar, isn't it? The indication number here is 80, so it's a lot more polar than other substances you see there. So polar substances can be, so ammonia, something that has hydrogen bond, 25. What's next one? Oh, well, methanol and ethanol, 33 and 25. So that's fairly polar as well. Acetic acid, compared to them, relative to that, it's not so much, a lot less. Okay, so that's polar solvents that you can use to dissolve polar things. Non-polar solvents include something that you have already used, cyclohexane. It's less toxic version of hexane because that evaporates and it causes cancer, I think. Benzene is the same. It's very stable, doesn't want to break down, and it causes cancer. So you don't want to have that in petrol. Chloroform, so something that knocks you down if you sniff so much of it, that's considered to be non-polar. But it's very small too, so it still can dissolve, and we'll talk about that in a minute. Diethyl ether, now if you go to uni and do chemistry, you might use that a lot. You've got oxygen in the middle, and you've got two carbon chain wings almost. So it's like a, kind of like the bird sort of looking structure there. So you can see that that's going to be a non-polar structure as well. I'll switch to this. All right, next. Now, I want you to try completing the table below by writing what sort of solubility they would have if you put polar solute into polar solvent, polar solute into non-polar solvent, non-polar solute into polar solvent, and non-polar solvent. All right, so only 4 things, but try writing that. Now, what I mentioned before, something like chloroform, is very small, tiny molecule. Okay, it's considered to be non-polar because there are 3 chlorine and 1 hydrogen there. Or even methane and ethane. They're usually gas, but they can actually dissolve into water. Okay, so methane, ethane, propane dissolve into water. Sorry. Hydrocarbon with less than 6 carbon in a chain can dissolve into water. Now, having said that, butane or pentane, 4 carbons or 5 carbon chain hydrocarbons don't readily dissolve into water. Now, at this point, I will probably ask you to do those questions, but yeah, we'll do that in class, okay? That's related to what I just talked about. So I'll just zoom in a bit again. So if it's an alcohol, methane, ethane, propane with ON, so yeah, methanol, ethanol, and propanol, they would dissolve and mix with water if you had 100 grams of water. So, but virtually what it's saying is that you can add as much as you want, and they'll still dissolve. When it comes to butanol, butane 1O, okay, or pentane, octane, octanol, octanol is insoluble. It does not. You can say that immiscible. Okay, pentanol is slightly miscible. Okay. Aldehyde, it's not very polar thing. So methanol can dissolve or dissolve into water. It's soluble in water, I should say. Ethanol is the same. When it comes to propanol and butanol, it's considered to be less polar, much less polar. So it doesn't really mix with water. Slightly for pentanol and octanol. If you look at carboxylic acid, COOH group is highly polar group. So methanoic acid, ethanoic acid, propanoic acid, and butanoic acid, they can dissolve into water, soluble to water. But when it comes to pentanoic acid, octanoic acid, not so much. What you can see is that no matter what functional group it's attached to, they are considered to be insoluble. Now, we will do a bit of C task practice using this information. I want you to be writing thesis sentence, so something that talks about what the report or paragraph will be about, mentioning one of the C key concepts. Okay? Then, based on your choice of your topic from the list, as well as the thesis sentence you wrote, so what key concept you're focusing on, I want you to write at least one paragraph about it, and we'll compare how you could intentionally make connection to the interaction between science and society. And yep, once you're finished, you will do some more questions. They are just C connections and key concepts written down. So that's really that. All right, I'll see you in the next video and the lecture.